Alright, in this video I will talk about eutrophication, which is what happens when we have too many nutrients in an aquatic environment and what that will do. And we'll talk about why some nutrients are good, too many nutrients can be really bad. This is section 21.3 in the syllabus on the pollution, and in your book here it is page 303 to 304. I will in this video talk over a PowerPoint. I will much rather teach you live, but this is what I have to work with now, so please stay with me. So today I'm going to talk about eutrophication, which is when an excess amount of nutrients leads to algae growth or excessive algae growth, and in bad cases this can lead to hypoxia or even anoxia in the water. But before we dig into the textbook, let's take a trip out in the real world. So today I'm going to talk about eutrophication, and I'm down here at my local lake, as you can see. And at this time of the year here, our lake here is clear and quite nice, but sorry for the wind. When we get to summer, we will see that there's a lot of algae growing around the lake. So our lake down here takes a lot of the surface water from the entire city, and it takes surface waters from the field surrounding here. So there will be a lot of nutrients washed into it, and when then we have light and warmth during the summer, we will see eutrophication here. But at this time of year here, it's absolutely beautiful. So, as you might remember from chapter 20, algae is an important part of most food chains and food webs in the marine or aquatic environment. They form the first trophic level and is food for all the other organisms in the food web. So how can algae in water then be bad? Well, they aren't necessarily bad. It all depends on how many. Algae themselves produce oxygen, and they are the basis of the primary production, but they're often limited on the amount of nutrients. That is why, for example, in the open ocean we see a very low primary production, while in areas near the coast we can see a higher primary production because the runoff of nutrients from land leads to a higher production of algae. So when we have excess nutrients, mainly nitrate and phosphorus, it leads to rapid algae growth if the climate is warm enough and we have enough sunlight. That is in Denmark often during summer. This can leave the lake or the fjord or the marine area covered by green algae. And this looks kind of weird, and it's not very good for the ecosystem. So when we have a lake covered by algae, what happens is it blocks the light. So plants on the bottom, or if you're on the ocean, macroalgae at the bottom won't get any light, which means they'll wither and die. Eventually the algae themselves will start dying and they'll fall to the bottom. When they fall to the bottom, bacteria will start rapidly to grow and break them down, because now they have a lot of food and bacteria growth can happen rapidly. When they do so, the bacteria will use up a lot of the oxygen at the bottom, and they'll use up oxygen faster than it can be produced, so we'll have a case where the water starts becoming hypoxic, which means low in oxygen. And now we have a bad case where oxygen level starts to drop, rapidly affecting the life in the lake or in the ocean. So why is hypoxia worse in the summer than during the rest of the year? Well, let me try to draw this. If we have a lake here, and I mean it's a badly drawn lake. Now during summer we have a lot of sunlight here coming in here, so algae, if there are enough nutrients, will grow a lot of the surface. Now those algae will then eventually sink down to the bottom, and bacteria will start to break them down. By doing so, they remove oxygen, so we will have hypoxia here, which means low oxygen. Now, during the summer, we also see another thing, both in the marine and in the aquatic environment. We see what we call a thermocline. And the thermocline comes from the fact that hot water has a lower density than cold water. So the warm water here will stay on top and the cold water will lay at the bottom. This means that if we don't have a lot of wind, there'll be very little mixing. So while there'll still be O2 produced up here due to algae being alive, down here where there's less light, there'll be less oxygen production, there'll be higher respiration, and we'll have no mixing of the layers. So down here we'll have low O2. So while there might here in the top be enough oxygen, down the bottom we will see the animals living at the bottom. They will either start to die or start to migrate. Now in worst case scenarios, if the bottom really gets badly affected by hypoxia or anoxia, we can have bacteria down here who then release methane and sulfur and other gases, which then in really bad scenarios also can kill the life up here in the top zone. But it's due to the fact that the warm water stays on top and the sunlight powers the algae is why this hypoxia induced by eutrophication is worse during the summer. Thank you. So, what is the source of the nutrients that causes eutrophication? One major source can be untreated sewage. If we have untreated sewage running from a city or a factory straight into a river or a lake, that can in itself be toxic, or it can contain so much organic matter that it will lead to bacterial growth, which then will lead to hypoxia. It can also lead to algae growth, which then through the process of eutrophication leads to algae growth. Runoff from the fields is also important. When you're doing farming, you want your fields to have a high yield, and one way of doing this is using fertilizers, either artificial fertilizers or manure, shit from cattle, pigs, so on, which contains a lot of nitrogen. This is of course good because it causes your crop to grow faster, but if you have a massive rainfall, what can happen is a lot of the nutrients will then get washed out into the rivers and lakes, and then you'll have eutrophication. Also, we have spill-offs from farming. Here in Denmark, we can't really use the manure from the cattle and the pigs during winter, so it is contained in huge tanks, so it can be used during spring. But if one of those tanks leak, well, then the manure will run straight down into a stream or a river, and that can cause bad eutrophication as well. So this is a case of we do need fertilizers on our fields. It's important for farming, but we also need to try to limit the amount of fertilizers that runs from the field into our aquatic environment. So this is a trade-off. If we want our very high yield fields that can affect our aquatic environment negatively, or on the other hand, if you want really clean lakes, it might lead to restricting some of the farming near those lakes.